My name is Chloe, and I will be presenting on the effect aerosols have on the atmospheric circulation and the movement of clouds. So, it is very important to understand the net effect clouds have on climate change. Some clouds, like cirrus clouds, which are high-level clouds, have a warming effect on the climate, while other clouds, like stratiform clouds, have an overall cooling effect on the climate. It is important to understand the net effects clouds have on climate change because adaptations and/or solutions will be made or adjusted based on such. Stratiform clouds are low-level clouds that reflect sunlight and therefore have a cooling effect. Because they have an overall cooling effect, they're very important to combat climate change. So on the left, we have a diagram of cirrus clouds and stratiform clouds. The higher level clouds are wispier, and therefore the sunlight pierces through these clouds and is absorbed into the Earth's surface. And because of that, they have an overall warming effect. While the cloud on the right, which is a low-level cloud, it reflects the sunlight back into the atmosphere, which you can see by the yellow arrow, and therefore they have an overall cooling effect on the climate. Airform clouds affects downstream weather, like precipitation, storms, humidity, and that affects our daily lives. So atmospheric conditions like wind affect cloud movement and more specifically stratiform cloud movement. Recently, there has been a rise in aerosols in the atmosphere. Our aerosols are tiny particles that are suspended in the air like dust, ash, and soot. Because of the increased amount of aerosols in the atmosphere, there has been a decrease in wind speeds. In 2020, most of Europe experienced a wind drought where wind speeds dropped by almost 15%. Because of this wind drought, there's an energy shortage and a decrease in cloud movement. On the right here, we have a diagram that shows different types of clouds and their movement. So red, orange, yellow, green are lower level clouds, and then blue to purple are higher level clouds. And the arrows of these clouds show the movement of these clouds. Because an increased amount of aerosols in the atmosphere leads to a decrease in wind speeds, and stratiform cloud movement is dependent on wind speeds, we want to determine the impact aerosols have on the movement of stratiform clouds in Europe. So for our materials and methods, we will be using 3 different data sets. For the characteristics of clouds, we will be using the International Satellite Cloud Climatology Project to get data. And for wind speed data, we will be using ERA5 data. And for aerosol data, we will be using the NASA MODIS observations. So the data will be merged for statistical analysis, and 3 sets of statistical analysis will be performed. The first one we will be performing is to determine the relationship between the density of aerosols in the atmosphere and wind speeds. So for this, we will be performing a regression correlation analysis. Then we will be performing regression and correlation again to determine the relationship between wind speeds and the movement of stratiform clouds. And finally, we will be looking at the relationship between the density of aerosols and the movement of stratiform clouds to see if there's a direct relationship, to see if the amount of aerosols in the atmosphere directly affect the movement of stratiform clouds. Expected results. We expect to see a decrease in wind speeds as there is an increased amount of aerosols in the atmosphere. We already know that this is true, however, we will be performing statistical analysis again to verify our data and see if it matches up with what we already know. So expect to see an increase in the movement of stratiform clouds as wind speeds increase because the movement of stratiform clouds is dependent on wind speeds. And finally, we expect to see a decrease in the movement of stratiform clouds as the amount of aerosols in the atmosphere increase. So because an increased amount of aerosols in the atmosphere leads to a decrease in wind speeds, and a decrease in wind speeds leads to a decrease in the movement of stratiform clouds, we expect to see a decrease in the movement of stratiform clouds as a direct result of the amount of aerosols in the atmosphere. It would suggest that an increased amount of aerosols in the atmosphere leads to a decrease in the movement of stratiform clouds in Europe. So one limitation of this study is that other factors may have affected the results. An example of this is jet streams. Jet streams are fast-moving and narrow air currents in the atmosphere. They're extremely rare and increase the wind speeds by a lot in a particular area. However, if jet streams were picked up in the datasets for wind speeds, it would not be a reflection of the actual wind speeds in a particular area and may have affected or may affect our results. For the future, we would like to isolate the variable of the amount of aerosols in the atmosphere, so things like jet streams do not affect our results. And we can do this by performing computer simulations, which we are not able to do because of the complexity of developing them. However, it is something that should definitely be looked into in the future. We would also like to study the effect an increased amount of aerosols has on the movement of different types of clouds, not just stratiform clouds. So we would like to look on the effect aerosols have on cirrus clouds, which are higher clouds compared to stratiform clouds, which are low clouds, to understand the net effect aerosols have on clouds. And we would also like to look into the effect the amount of aerosols in the atmosphere have on the movement of stratiform clouds in other areas of the world, because in this study we solely looked into Europe because of their recently experienced wind drought. Sources, and thank you so much for listening. I hope you all enjoyed.